Okay, in this video, I'm going to go over the homework for 10.6, and we're going to use this as a review for a very short little quiz that we'll do on this topic next class. Okay, so what I did when I set up the homework is I wrote next to each problem which theorem applies to it in this section. So theorem 1 talks about two chords, and if the chords cross each other, what happens, remember we're looking at the chords, not at the angles. So we have this number and this number, so that product has to equal this product. Okay, so that's what the theorem says. So what we're going to say is, okay, in that light, 6 times x has to be 9 times 4. Okay, 9 times 4 is 36. So 6 times x equals 36. Divide both sides by 6, and you're getting, for that to be true, x has to be equal to 6. Okay, so 6 is our answer, but I want you to also do a check. So your check happens when you take your 6 that you got for your answer and you plug it in your x, and then you check. Does it make sense that 6 times the 6 we just found does it indeed equal 4 times the 9, like it says in the theorem? So 6 times 6 is 36, and that does indeed equal 36. So we know that we are correct, and we've done this problem according to the theorem. Okay, so this is what I'm looking for. I'm looking for the answer, and I'm also looking for the check. So when we do our quiz, each will be worth 1 point. Okay, let's go on to the next problem. So in the next problem, what we see is that we have a tangent. So this line is a tangent, and this other line that hits the circle twice is a secant. And in theorem 3, we are told that the pieces of the entire secant, okay, so this is the entire secant, that times the, let me just highlight this, times the external piece equals the tangent piece squared. Okay, so go back, look at that theorem if that does not sound familiar to you. So what I'm going to say is, let's set it up. The theorem tells me that the entire secant, which is 12 plus x, times the external piece, which is the 12, equals the tangent squared. Okay, so what I'm going to do is we're going to do some multiplication here. So 12 times 12 is 144 plus 12x equals, and let me find out what 18 squared is. So 18 squared is 324. Okay, that's our first step. So what I did was I distributed here and here, and that's how I got the 144 plus the 12x. Okay, so now I have a two-step problem. First step, subtract the 144 from both sides, and 324 minus 144 gives me 180. So 12x equals 180. Next step, divide both sides by 12. So 180 divided by 12 gives me 15. So 15 is our answer. Okay, so this is our answer. And now let's do the check. So here is the check. So I'm going to do it, I guess, up in the corner here. So I'll do it in green. So my check is this. The theorem tells me, so x is 15, that the whole secant, which is going to be 15 plus 12, which is 27, times the length of the exterior part of the secant, which is the 12, has to equal the tangent squared. So 27 times 12 is 324. So So we're checking this, so it's unknown here. And then what I realized is that 324 is also 18 squared, so it checks, so I'm good to go. So that's a second point for that problem. Okay, looking at this next one. Okay, these two lines that are coming into the circle are secant lines. So that's why this is part 2, or theorem 2. So our setup is this. So I'll change color. The entire, so over here I'm going to do it. The entire secant line times the outside has to equal the entire secant line, so 7 plus 5, times the outside. Okay, so let's clean things up. 7 plus 5, that is 12, and 12 times 5 is 60. So this is 60. This is 6 plus x times 6. Okay, so this time, instead of distributing, I'm going to take the initiative and just divide by 6. That gives me 6 plus x equals 10. Subtract 6, subtract 6, and I'm getting x equals 4. Okay, so that is my answer. Now let's do the check. So the theorem tells us, so I'm going to write check, that the entire, and this is going to be 4 now, the entire secant line, which is 6 plus 4, which is 10, times the outside part, which is the external, has to equal the entire other secant line, which is 7 plus 5, which was 12, times its outside piece, which is the 5. So that's a question mark. Do they equal each other? Well, this is 60, and that does indeed equal 60, so it checks, and we are good to go. Okay, moving on to the number 4. In number 4, we're back inside the triangle, having two chords cross. So when that happens, the pieces have to multiply together in each chord. So the theorem's telling us that 9 times 8, which are the different pieces of this first chord, must equal, let me highlight the second chord, 6 times x. So it must equal 6 times an x. So 9 times 8 is 72, and that equals 6x. Divide by 6, divide by 6, and I'm getting x equals 12 for my answer. So that's my answer. So now let's do the check. So to check it, I think I'll write check over here. We're going to use our 12, which is over here, and I'm going to say, is it true that 9 times 8, does that equal 6 times 12? 9 times 8 is 72, and that does indeed equal 6 times 12, which is also 72. So that's my check. Okay, just a couple more. Okay, 5, I have theorem 1 again, because this is inside the circle. And so the different pieces of the individual chords have to equal, their products have to be equal. So this products, those products, and these products have to be equal. So here's your setup for theorem 1. 15 times 8 has to equal 10 times x. Okay, so 15 times 8, what is that? You should be saying 120. So this is 120, has to equal 10x. Divide both sides by 10. 12 equals x, and that's our answer. Now let's do the check. So to do the check, I'm going to plug in the 12 over here. And I'm going to say, is it true that 10 times 12, does that equal 15 times 8? Well, I know that 10 times 12 is 120, and I also know that 15 times 8 is 120, so the check works. Okay, moving on to question number 6. These are secant lines. So what's going to happen is the entire secant line, which is 10 plus x, times the exterior piece of it has got to equal the entire secant line, which is 9 plus 11, and that's 20, times 9, which is the exterior piece of it. Okay, so I'm going to do this. So 9 times 20 is 180. So I'm just going to rewrite this piece, and I think I'm going to continue to keep the numbers small. So to do that, what I'm going to do is divide, oops, so sorry. Divide both sides by 10. So if I divide this by 10, it's gone. Divide this by 10, and I'm getting 18. So I have 10 plus x equals 18. So x will equal 18 minus 10, which is 8. And let's check to make sure this works. So I'm going to plug in, because that's my answer, but I need my check still. So here's my answer. Okay, so now we're going to go here, and we're going to do the check. I'm going to plug in the 8 over here, and is it true that 18 times 10, does that equal 20 times 9? And 18 times 10 is 180, and 20 times 9 is also 180, so that checks, and we're good. Okay, 2 more problems. Okay, this next one, number 7, is a tangent line that touches just once, and a secant line. So theorem 3 tells us that the entire secant line, which is going to be 4 plus x, times its exterior piece has to equal the tangent line squared. So let's work on keeping our numbers small again. I'm going to square that. I'm going to rewrite this using my parentheses, and I'm going to divide both sides by 4. 4 plus 8 equals 9. So x equals, subtract 4 from both sides, and x equals 5. Okay, that's my answer. So now let's do our check. So to do the check, I'm going to plug in that 5, and I'm going to say the entire secant, which is 5 plus 4, so this is going to be my check here, 5 plus 4 is 9, times its exterior piece has to equal the tangent squared. And I'm not sure if this is true until I do the math. This is indeed equal to 36, and my answer checks. Okay, last one. I'm back inside, therefore I'm using theorem 1, and I have pieces of chords. So the rule is the product of the pieces of one chord has got to equal the product of the pieces of the other chord. So this is 60 equals 5x, divide both sides by 5, and I'm getting x is 12. That's my answer. Let's quickly do our check. So here's our check. Plug in the 12 here, and the theorem tells us that the product of the chord pieces must equal each other. 5 times 12 is 60, and 6 times 10 is also 60, so that works. So our check also worked. Okay, so big picture. You have to recognize the scenario you have. So that means that you want to go back over here, and when I talk about the theorems and I identify them and we go through them, you've got to understand what they mean. Okay, so here's where the initial explanation is. I kind of did a lot of highlighting there as well. Those are your theorems. Based on those theorems, you're going to solve for the missing values that you see. Okay, there are always x's that are missing, and you have to first identify what the theorem is, and then identify what your procedure is going to be. Once you implement your procedure that follows the theorem, you're then going to have an x value. You're going to check that value by checking your work and plugging in the x and then using the theorem again. So this is a two-part problem. So on the quiz, I'm going to ask you, I think, maybe 6 of these, give you 1 point for the answer and 1 point for a correct check. Okay, so go over this. We'll talk about it in class, and you should be good.